what we have here is our ratios in similar polygons. So the definition that we say for similar is that they have the same shape, but not always the same size. Okay, so it's not congruent. It's similar. They look similar to one another, like your siblings. You and your siblings may look similar, or you and your parents may look similar, although one may be bigger or smaller than the other. Your size is going to be different. Okay, and it's hard to see on your paper, but what this says in parentheses here is triangle 1, and it has this little tilde here, triangle 2, and this right here, this is the notation for similar. So for congruent, we had equal to with this, with the tilde. So you would congruent with the squiggly with the equals. For similar, we just have the little squiggly. Okay, and this one here says that these are not similar. So this says triangle 1 is not similar. Okay, so it's the squiggly, not similar. It's the squiggly with an arrow through it. And you can see that by these two triangles. This looks like kind of like a right triangle, whereas this looks like an isosceles. So we've got two different types of triangles here, and that's why they're not going to be similar. Okay, so properties that we want to be concerned with here is that your angles are going to be the same. So your angles will be congruent. That's what kind of tips you off to whether the triangles are going to be similar. So angle A is going to be congruent to angle D. Angle B will be congruent to angle E. Angle C will be congruent to angle F. Okay, and we can see that by all these markings that they have. This also says here a triangle ABC, and it has that similar. It's similar to triangle DEF, which means it's going to have these corresponding, what we call these, is our corresponding angles. But our sides are going to be different. And our sides, we call them, our sides are proportional to one another. So they're not the same, but they can, you can create proportions. We can create some ratios out of them, and you want to match them up just like we did before. So AB is going to go with DE, and that's going to be equal to, for our proportion, is going to be equal to BC over EF. Okay, and we can write all sorts of different ones. We can write AB over DE is equal to our other ones. Maybe we want to talk about AC and DF. Or we could talk about these two together, BC over EF equal to AC over DF. So all sorts of different proportions can be written from these side lengths here, and even more when we have a four-sided figure of quadrilateral. Okay, so for describing our similar polygons, we want to identify the congruent angles and the corresponding sides, so the ones that are going to go together. And for this right here, we want to write a proportion. That's what this is asking us. So write a proportion for this after you talk about the congruent angles. So I see here angle J will be congruent to angle M, angle L will be congruent to angle P, and lastly angle K will be congruent to angle N. Okay, and then a proportion that I can write for this using both the letters and the numbers that I have. So I'm just going to pick two. Let's see, I'll do KJ. KJ is going to match with NM. It's going to be equal to, I'll do the long one, JL over MP. Notice I'm matching my letters J and M. They match here. And then you have K and N, they were matching here, and L and P. So that's helping me out to match them is my angles. Okay, you also, remember we talked about before, you can also write them right here. M could go here, P and N, that can help with the side lengths as well, and you can do it for these ones here. This is going to be the same as L, this one's going to be the same as J, and this one's going to be the same as K, and that can help you. Okay, and I want to write a proportion for this, so KJ is 16 over NM is 12 equal to JL is 36 and MP is 27. Okay, and you want to check whether these are equal or not. So I'm going to use my cross multiplication and check if they're equal. 16 times 27, is this equal to, oops, 12 times 36. So 16 times 27 gives me 432. 12 times 36 gives me 432. And these are going to be equal. Okay, so you want to make sure and check just to be sure. And our last one here, we want to determine if they are similar by using our ratios. I'm definitely going to put in which ones are matching with which for this. So I see J and F are the same. So this is the same as J, this is the same as K, and this is the same as H. So that should help me here. I really want to write a proportion again and check it. So I'll use side lengths FE, and I can see that that's going to be the same as JH, equal to, and I'm checking this out, oops, FG over JK. Okay, and so this means FE is 10, JK is 8, JH is 15. Is this going to be equal to FG, which is 12, over JK, which is 18? And again, I have to check my ratios here. 10 times 18, is this going to be the same as 15 times 12? So 10 times 18 gives me 180. 15 times 12 gives me 180. Ooh, that's an 8. So this is all set. So triangle EFG is similar to triangle HJK. That's what we wanted to find out. Okay, and the last part, a rectangle is 3.2 centimeters wide and 8 centimeters long. A similar rectangle is 5 centimeters long. I'm going to draw these out. So I have 3.2 wide, and I have 8 going this way. And then I have this other rectangle that's 5 long, and we want to know what this is, and we can use X for that. Okay, so we want to make a proportion for this. So we want to go, you know, wide over long as our ratio and set them equal. So 3.2 over 8 equals X over 5. Down. And here's where I want to do my cross multiplication. I'm going to have 3.2 times 5 equals 8 times X. So 3.2 times 5 gives me 16 equals 8X, which means that I get 2 equals X. So the width here, X equals 2 centimeters. And that's it. So these should be helpful to complete the rest of the packet.